Well, this is the second video on drawing Lewis structures from a molecular formula. I wrote this NO2H, but it's the nitrous acid, not nitric acid, and it's commonly written HNO2, so that was an error on my part, but we'll work through the three steps: finding the valence electrons, framing and filling in with electrons that are, I guess, needing to be added in, and then dropping down lone pairs if we need to. Now this one's an interesting starting point because a lot of students in the framing, they'll get the central atom right in, but I want to put two choices. Students will either do one of two things. They'll draw this as a possible frame and we'll chase that down, or they'll draw this as a possible frame. Knowing that the H can only make one bond, they'll sometimes put it off the oxygen. And what I would recommend to students, and this is what's so lovely about chemistry, is just chase both down and see which one seems to be more stable. So we'll go on to the filling in with electrons, the dots, with both of them and see how they do as we progress. Now I skipped the first step, which is determining number of electrons. So H is 1, nitrogen is 5, and oxygen is 2, but we have to times, it's 6, but we have to times that by 2. So we have 12, 17, 18 electrons. 18 electrons have to get into the structure that we're building. Well, then we look at this one. It has 6 already in, so we need to add 12 more. And we look at this one, and we see that we need to add 12 more. Now remember, we would do it from the outside in. So on this one, it's going to be pretty simple. I'm going to go ahead and leave the H alone. Only the folks that, well, I can't say since this video, the other school, not Pratt Community College, might put dots on the H, but we don't do that because we know hydrogen makes one bond and he's satisfied. He has 2 electrons in his valence shell, which we now know to be the 1s, and he's using that for bonding and he's done. But the oxygen, we then put the remaining 12 electrons around it as dots. 12, 2, 4, 6, 8, 10, 12. So this would be our frame that we're going to consider, but we also said we're going to look at this other option, and again, just go ahead and start filling in with electrons. We have 2, 4, 6, 8, 10, and unlike the one up here, we're going to be able to put 2 dots on the nitrogen. We have to. You can't put dots here. This is satisfied. You can't put more than 4 dots around it or 2 lone pairs, and this has 3 lone pairs. We had to put it here. Now, as we consider dropping down, remember we had the framing around the center, that's just the nitrogen. We built the frame. We added in lone pairs, and we dropped down lone pairs if needed. Well, this nitrogen certainly needs 2 more electrons, and so does this one. So we're going to go ahead and draw the two possible structures, that Lewis structures. We'll do this one first. We'll say we could come from the, just like on the last video, we could come from the left or we could come from the right, but we can't come from both. So we're just going to understand this is one of 2 resonance forms that I can possibly draw. And the oxygen here would have his remaining 2 lone pairs, but he used one of them to make this double bond. And that's, again, if you do it this way, we work within what we have to go from here to our final Lewis structures, dropping down if needed. Here, though, we notice the oxygen has a negative charge. Why? Because he has less than the 2 bonds he wants. And this nitrogen here, we notice, has a positive charge. So this is just the facts it's going to have, and you can't get away from it. You could put the negative here and have the double bond on this side, but this is I guess, a zwitterion, we call it. It's got a positive and negative charge. But for this one, we're going to not come down this way. We don't want to give this oxygen more than 2 bonds, but this one wants to have 2 bonds. And this nitrogen, more importantly, needs to have 8 electrons. He only has 2, 4, 6 around him. So we're going to draw that structure. And then we'll look at these two possible Lewis structures, number 1 and number 2, and see which one's more stable. As we look at this structure, there's no charge at all. H's has 1 bond, O's has 2 bonds, has 8 electrons around it. Nitrogen has 1, 2, 3, and a lone pair, which he likes, so he's neutral. And this oxygen has 2 bonds off of it and 8 electrons. So happy, happy. This is actually the favored structure. Now before we end, we want to make sure we cover shape and polarity. You should check out, if you can, mole view for all these if you want to know what the dipole moment is, just to confirm, does it fit what I think it is? Well, we know this nitrogen is not as electronegative as the oxygen. So, for geometry, I forgot. We got to get that first. We know the nitrogen here has 1 atom off of it, a 2nd atom off of it, and a lone pair. If you look at the rule again for the group number, it's the number of atoms off of it and the number of lone pairs. He has 2 atoms off of this nitrogen and the lone pair, so that's a group number of 3, group count, and that's trigonal planar. And don't forget, we don't count the double bond, you don't count it twice. It's just atom, atom, lone pair, 3, trigonal planar. So we would have 120 degrees between the O, the oxygen, and the lone pair. That's helpful because we now know the geometry of the bond polarities. So this is kind of towards the oxygen, and we're going to make that a pretty strong bond polarity arrow because there's a double bond. Then we have a little bit of an arrow here towards this oxygen, but it's a little bit more pronounced this way because you have 2 linkages to this more electronegative element than nitrogen, and it pulls electrons towards the oxygen. Remember, its electronegativity increases in the periodic table up and to the right. Oxygen is to the right of nitrogen, and so this is more electronegative. So this would not be canceled by this one, even if they were the same length, because they're both going down. So we do have a dipole moment. Yes, we have a dipole moment for nitrous acid. Nitrous acid, HNO2. This is our final structure. Thanks, I hope that helps. Remember to always find your electrons, build your frame, put in the electrons that are additional that we need to add in, drop down if you need to, we did that. Checked out charge, negated this possible Lewis structure. This became the winner chicken dinner. We looked at the the geometry and the bond polarity, and since these don't cancel out, we have a dipole moment. Thanks. Bye-bye.